Have you ever wondered about the space complexity of an array? It might sound complicated, but understanding it is crucial for optimizing your code. Today, we're diving into the space complexity of arrays, specifically when the size is up to 200. I totally get it. Space complexity can be a tricky topic, especially when you're trying to optimize your algorithms. You're not alone in this confusion. Many developers face the same question. Here's the specific question we're addressing today. A user asked, what is the space complexity of an array of size n, where n is less than or equal to 200? They are curious whether it is O1 or On. Let's break this down together. To understand this, we need to look at what space complexity means. Space complexity refers to the amount of memory an algorithm uses in relation to the input size. In the case of an array, the space it occupies is directly proportional to its size. And stick around. At the end of this video, I'll share a quick tip on how to manage space complexity effectively in your projects. To determine the space complexity of an array, we first need to understand what space complexity means. It refers to the amount of memory an algorithm uses in relation to the input size. In this case, the user has an array of size n, where n is less than or equal to 200. This means the array can hold a maximum of 200 elements. When analyzing space complexity, we consider both the space required for the array itself and any additional space used by the algorithm. For a static array, the space required is directly proportional to its size. Since the array size can vary from 1 to 200, the space complexity is On. However, because n is bounded by 200, we can also say that the space complexity is effectively constant in this specific case. In summary, the space complexity of the user's array is On, but due to the constraint of n being less than or equal to 200, it behaves like O1 in practical scenarios. Fun fact: did you know that the concept of space complexity was first introduced in the 1970s? It's amazing how far we've come in understanding algorithms since then. Now, let's look at the answers provided by other users. This user explains that the space complexity of an array depends on the specific case. If you use a constant amount of memory, the space complexity is O1. However, if the array size varies with input, like a one-dimensional array designed to hold n elements, the space complexity becomes On. For a two-dimensional array of size n by n, the space complexity is On squared. They illustrate this with an example where the total space requirement is 2 plus n, leading to a space complexity of On. Now, let's shift our focus to a different response. This user believes the space complexity of the array is O1. They explain that space complexity is On when it increases linearly with n. However, since the size of the array is capped at 200, the function does not depend on n beyond that point. Now, let's dive into a different answer from another user. This user points out that simply having an array of size n, where n is less than or equal to 200, doesn't provide enough context to determine space complexity. They emphasize that without an algorithm or code utilizing the array, we can't measure space complexity meaningfully. They explain that if the array is used in a function that creates multiple instances based on n, then we can analyze how space grows with runtime. However, in this case, since there's no code executed, the space complexity is O1. Here's that quick tip I promised. Always consider the maximum size of your data structures when analyzing space complexity. This will help you make better decisions in your coding projects. And there you have it. The space complexity of an array of size n is On. Understanding this concept will help you write more efficient code. If you found this video helpful, please subscribe for more insights. And don't forget to check out our next video for more tips on optimizing your algorithms.